Hello, everybody. My name is Maria Huang. I am the Assistant Professor of Computer Science in the Department of Science and Math at the Fashion Institute of Technology. So welcome, everybody. So I hear that today we might be having people joining us from France and Mexico and the United States, maybe some other countries I'm not aware of. But anyways, welcome everybody and thank you for being here. And it's an honor to be here. I hope this talk can be useful and enjoyable for all of you guys. All right, so what we're going to talk about today is how artificial intelligence and/or machine learning is changing the fashion industry. But before we get into what we will be talking about first, I would like to start with a disclaimer. These are my personal opinions. In this presentation, this will all be my personal opinions about AI and machine learning, as well as anything that I refer to in the fashion industry. I will be talking about specific brands and companies, but I don't have any personal affiliations with any of those. Those are, they just came up as I was doing more research about the fashion industry because I'm not from the fashion industry personally. So I had to do a little bit of research myself. So those are the things that popped up, and I personally don't have any affiliation or relationship with any of those. So just keep that in mind moving forward. Okay, so let's talk about the agenda of this presentation today. So first, I am going to do a little bit of an introduction to the concept of AI and machine learning. There sometimes could be a little bit of confusion, so we'll go over that briefly, but in depth enough that you will have a solid understanding of what that might mean. And then moving from that, with those definitions in mind, we will talk about various applications of AI and machine learning in the fashion industry. And then throughout that, I will be asking some questions, some food for thought, where we might be heading in the future. Some of the things that we might want to consider moving forward, and some of the things that we presently are dealing with, some dilemmas that we might have with all the technologies and the pervasiveness of it. So that's where we will going, and I'll probably leave you with a few questions to think about so that maybe in the future we can have a Q&A session, whether synchronously or asynchronously, but I think that would be very good. All right, so this is our overview, and let's get into it. First, before we go into some formal definitions, I would like to kind of give you some like nuggets how you could be thinking about these phrases: data science, machine learning, and artificial intelligence. There is these buzzwords, those buzz phrases are used a lot and thrown out a lot without maybe exactly knowing what they are. But in a nutshell, if it's hard to kind of think about the definition right away, what I like to think about is data science is a field that will provide insights for you. And machine learning is very particular in terms of using algorithms to make predictions. And we'll touch a lot about this a little bit later. And then the artificial intelligence is the actual actions, something that happens, kind of like self-driving cars. So this, I think, is a good way to think about these different phrases moving forward. But we'll also get into some of the formal definitions. Okay? All right. So what is artificial intelligence? The easiest way to think about artificial intelligence is in the context of a human, in my opinion. After all, humans are the most intelligent creatures that we know of so far. But anyways, AI is a broad branch of computer science. So in the umbrella area of computer science, artificial intelligence is one area. And the goal of AI is to create systems that can function intelligently as well as independently. And then within AI, there is a section called machine learning. And machine learning really focuses on these algorithms that give the ability to computers, or any machine for that matter, to learn from data and make predictions. Again, this concept of predictions is very important when you think about machine learning. So you really want to be like machine learning predictions, machine learning predictions. So those are some ways to distinguish AI and machine learning that machine learning is part of AI. It is often used interchangeably, like AI and machine learning, and that is fine because there's a lot of overlap. But to be more concrete, and if you want to be more exact, artificial intelligence is a bigger umbrella, and within that, we have a small area of machine learning. And I will go into a little bit more detail about how to distinguish that and what that really means and what the nuance differences is. Okay. Make a little diagram, if you will. So at the very top, we have computer science. And then computer science is a very broad field. But if we'll just like simplify for our purpose today. So AI is one of these subfields, and there's many subfields in computer science, but we're just going to focus on AI today. So there is two ways how AI works. One is symbolic based. We won't get into it too much today. Learning. And the best way to think about this area of AI is through computer vision, which we might have heard about a lot. Computer vision. And really, the other area of AI that we are pretty much interested in is very data-driven, and that is where machine learning comes in. For the database side, so this is kind of like the database side. Oops. So this is the database side, right? So what we need to do for machine learning is we need to feed the machine lots and lots of data. And over time, the machine will become more and more intelligent, learn about different patterns of the data, and therefore be able to make predictions based on those data. So it's always data hungry. We use that term sometimes because it wants more data, and the more data you have, the better it is. For example, if you had lots of data for sales versus advertising, you can plot that data to see some kind of pattern. So if I were to make maybe a little bit of a graph right here, I'll just do like a two-dimensional graph. Oh, I see. Okay. Maybe I'll like draw it like this so you guys can see. And this is just a very like simple example. And let's just kind of plot all these different data points. It's going to make it all like dots for now. And you could say that this is like a relationship between sales versus like money you spent on advertising, for example. And it is very likely that the machine will be able to find a pattern between those two variables, something on those lines like this, right? And that's pretty simple for even us to understand, and of course for a machine as well. However, and then when the dimension gets higher and higher, we're pretty good at going up from maybe 2 dimensions, maybe 3 dimensions, and maybe one more or so. However, when the dimensionality really increases a lot, it will be more difficult for humans to understand this. However, how many dimensions there are for the data, the machines have a unique capability of process all of that very fast, very efficiently, without getting tired, for example. You know, you could be running machines all night long, 24/7, and they won't get tired. They won't make mistakes because they're getting tired. They won't form unions and be like, we need a bathroom break or anything like that. So really, this is kind of the strength of machine learning, where as long as we have sufficient data and we can feed it in, then it just could run and run and run and detect patterns over time and really get better at what it's supposed to do, which is making predictions. Okay, so now let's talk about the human brain just for a few seconds. And let me kind of get rid of this right here. So the human brain is a network of neurons, and we use these to learn things. If we can replicate the structure and the cognitive capabilities in the human brain to machines, that's obviously something that we are aiming for and will be absolutely amazing. This is kind of getting into the area of neural networks. So in machine learning, I guess you can't see it right here, a branch of machine learning, and I'm mentioning this because I'm sure you have come across deep learning. And so deep learning is a part of a subset, a subcategory of machine learning. And if these networks are more complex and deeper, and we use those to learn complex things, that's the field of deep learning. And also, sometimes you will hear people using deep learning interchangeably with machine learning, but it is a little bit more nuanced, and it is part of machine learning. There are different types of deep learning and machines, which are essentially different techniques to replicate what the human brain does. So that's kind of another subset of machine learning where a lot of research is going on as well. If you might have heard of a few different areas in deep learning. I won't go into details of it, but if you have, there's something called convolutional neural networks, abbreviated as CNN. And then there's also recurrent neural networks, abbreviated as RNN. And that's pretty much as far as you probably will ever go into unless you are really doing research in this area. So just even though a lot of phrases are thrown out here and there, we have a big area of computer science, which I'm sure everybody has heard of. And then within that, a sub area is artificial intelligence. And then artificial intelligence, there's like kind of two approaches. And one is a symbolic way, and one is a more data-driven way, a database-driven way. The symbolic way, the most simple way to kind of understand it is when you think about all the computer vision technologies. And then within AI, this is where within AI, when the approach is more data-driven and based on databases, we're really talking about machine learning, right? Algorithms that will learn from data. So data is taken in as the input, and then from that input over time and over a lot of sets of data, then the machine will learn different patterns. And then with that, we'll make predictions. And again, really, when you think of machine learning, you really want to almost equate that with predictions. It's very important. That's really the key of what machine learning is doing. And then within that, if you are really focused on more complex issues to kind of mimic the human brain, that's when we're talking about deep learning. And sometimes people will be mentioning that as well. Okay, so that's kind of an overview of where artificial intelligence, machine learning, and deep learning lie. Okay. One last concept that might be of interest to you is, and I'll use this other side of the whiteboard. Another way to think about kind of learning algorithms used for AI, if you train an algorithm with labeled data versus unlabeled data. So that will be over here. We distinguish that with supervised versus unsupervised algorithms. And as I was noting, really the difference is that the supervised has labeled data and the unsupervised version is unlabeled. Another way of saying this is basically if you are dealing with a supervised algorithm, you are providing the answers to the algorithm. So for example, a typical example would be Google Photos is good at recognizing maybe your friends. Well, how you start that is you give a picture, let's say of my face, and then you label it Maria. And so you already given an example with an answer, a labeled data to the algorithm. And then based on those labeled data, basically answers, it will go through all the photos and be able to label all the ones that look like Maria. And so that is a supervised learning algorithm. That's one way to approach AI and machine learning. And then the other set is unsupervised, where it's unlabeled. So in this case, you're just kind of throwing the algorithm with data, and you're not giving any answers or guidance, or there's no labels. And you just say, go and find patterns, and it will go and find these nuggets and patterns and go through all the data and see what it figures out. And that's in the category of unsupervised learning. For example, you might want to feed the data about celestial objects in the universe and expect the machine to come up with patterns in that data by itself. Something kind of crazy like that. If you give any algorithm a goal and expect the machine to learn through trial and error to achieve a goal, that is called reinforcement learning. So that's kind of like the last category, reinforcement learning. And so those are kind of another different ways of understanding artificial intelligence or machine learning, different algorithms, how different approaches to those things. And so in that way, I think we might be able to understand these concepts maybe a little bit better. All right. So what I now want to do is show a little clip of a video that I personally like that introduces the concept of AI and machine learning, but we'll skip over that part since we had a little discussion about that. And what I want to show you is the end part of it, as we think about where all of this is going in the future, right? Not just in the fashion industry, but just as how AI is affecting this world and the lifestyles and our daily lives. And it poses a good question, and it poses something to think about. I think that is a good message. So we'll do that, and we'll keep that in the back of our mind as we talk about different applications in the fashion industry and how that might be affecting our daily lives and decisions that we make as we live this new life, if you will. Okay, so okay.
But remember, machine learning is about making machines learn like humans. And like any toddler, that means they have to learn by experience. With machine learning, programs analyze thousands of examples to build an algorithm. It then tweaks the algorithm based on if it achieves its goal. Over time, the program actually gets smarter. That's how machines like IBM's Watson can diagnose cancer, compose classical symphonies, or crush Ken Jennings at Jeopardy! Some programs even mimic the way the human brain is structured, complete with neural networks that help humans, and now machines, solve problems. Generations have long imagined the ramifications of AI, visualizing a society where machines seek revenge and wreak havoc on human society. However, the more logical and pressing question is, how will AI affect your job? Will it make your work obsolete? Just like the Industrial Revolution, it's not human versus machine, it's human and machine versus problem. The point is that artificial intelligence helps you accomplish more in less time, taking on the repetitive tasks of your job while you master the strategy and relationships. That way, humans can do what they do best: be human.
All right. So I think it's very important to think about the different applications of artificial intelligence. So this video at the end talks about, oh, is it going to be some kind of war like us against machines or us against robots? But maybe that's not really the point. The point is that we utilize artificial intelligence, robots, or whatever it may be, to help us take care of some of the tedious work, some of the repetitive work, and some of the work that, as we discussed before, that requires a lot of data processing at high dimensionality. And that is taken care of by AI, while we can focus on what we're really good at, that human touch, the human experience, humans being human. So I really like that message, and I want to for us to kind of keep that in mind as we move forward with some of the applications we'll talk about in the fashion industry. And this is, again, my opinion, and this is how I view things, but you might have a different opinion, which is also great. So hopefully I'll get a chance to maybe interact with you guys one time at some point, and maybe receive some questions and have some great discussions as well. But for now, here we go. So these are some examples that I've done some research on in the fashion industry. All right. So one of the first areas that we can think about in terms of AI and machine learning having an effect is the supply chain and demand projection. So I believe it was 2018 when it was revealed. I don't think H&M meant to reveal it, but I think it was revealed, and it got a little bit of media coverage, that H&M was sitting on $4.3 billion worth of unsold inventory. And so you can imagine, it's a lot of money, first of all, but you can imagine using AI prediction analysis to be able to basically sell this inventory. Looking at past data, customer data, sales data, return data, seasonal, like promotional deals and all that kind of stuff to get rid of all this unsold inventory. Personally, you know, when free shipping is added to some kind of promotional deal, like as a customer, I'm very more likely to buy something, right? So looking at that past data, it could be very informative to making those kind of suggestions to get rid of the inventory. I'm sure H&M at this point definitely has a data science group that's looking into this. But for some companies, some examples that actually did make some profit or changes in their strategies, you can see on the bottom here, we have Rulala that collaborated with MIT to experiment with some AI technologies, and they used it to improve their demand forecasting. So they developed a system that could help predict the demand for products during flash sales. So in particular, they looked at all the flash sales, and they were looking at like brand information, product information, the colors and the prices of all these different items. And they were enabled to optimize the price and generate 10% increase in their revenue. And you might think, oh, 10% doesn't seem that much, but think about it in the context of H&M. 10% of 4.3 billion in unsold inventory, if it were that, that's a lot of money. So something, just a 10% increase in revenue is a really big deal for these retail companies. So you can see how AI technologies could really make a difference. On the right side of the slide, Otto is a German e-commerce player, and it used deep learning to analyze billions of transactions. And what that resulted in was being able to be 90% accurate in forecasting what it will sell in the next 30 days. So that may help them cut the surplus by 20%, and it reduced their returns by 2 million items. So that was a really big deal for Otto to invest in deep learning technologies. So the supply chain can definitely, and demand projection forecasting can definitely have some benefits for using AI technologies. Okay. Photos for new collections. So I love posing this to my students in a class. And I get to learn a lot of things too. But what I do is that I give them a scenario where they're a CEO, maybe for a new lingerie company, and they have a website where they have to feature these new collections. So we're going to go ahead and book a photo shoot and try to do one of these photo shoots. So then I ask them, okay, what will be involved in a photo shoot? And then they tell me things like, oh, of course you need the models, and then you need a camera crew, which I, would have expected too. But then there's all these additional things such as lighting crew, stylist, makeup crew. There's people who might have to arrange the backdrop and maybe kind of like the environment setting and decorations. There might be people who need to bring food and drinks, and the health and safety people now that it's the pandemic and stuff. You got to rent a place. You might need renter's insurance. You need somebody to schedule all of it. Later on, you're going to need somebody to maybe edit the photos. So some people with like Photoshop skills. I mean, the list goes on and on and on, right? And I get to learn about all these different things that could be involved in one photo shoot. And then I ask them, okay, so you're the CEO of this new lingerie company. Are you likely to do a photo shoot once a year? They pause for a second and they're all saying no. And you're probably going to do it multiple times. So to do this over and over is going to be a lot of work, a lot of scheduling, and definitely a lot of costs. So what I tell them is to imagine an AI solution for this problem. And some companies are actually doing this already at this point, right? So they're putting clothes on mannequins, and then they're replacing the mannequin with a 3D image of the actual model, as you can see on the slide here. So then you are doing a full photo shoot just from your computer at home and being able to produce this many times a year, as many times as you want. And you can imagine, especially during the pandemic, this could have been a very, very nice solution. So these are some ways how AI could really be helpful to save a lot of costs, right? Another area that I am particularly very interested in is the automated sorting part, especially for warehouses. So Gap in particular was investing in this for a while, and they invested in this company called Kindred, and they had a Kindred robot arm. That's what you're seeing, this yellow robot arm here. They invested in this so that the robot arm will take care of the whole sorting process in their warehouses. So I'll show you a little clip on what they're doing here. All right, so you'll see in the background how this is working. So this Kindred robot, they have these kind of little clips here, which will be the fingers, if you will. And it's picking up different items in what you would imagine a warehouse would have. And the interesting part is, and you'll be able to see this, depending on what it's picking up, it's going to have to use a little bit of a different force, maybe a little bit of a different grip, speed, and all those different physics components. So what happens is humans will control this Kindred sort robot arm and input this information, like how fast it is and how strong the grip is and all of that. And that will be used as an input data source. And that will be fed into the algorithm, as we talked about. And over time, so over data, the Kindred sort will be able to distinguish between, say, picking up a pair of sunglasses versus picking up a pair of pants. And obviously, those should be different. And then the a whole process can be automated very fluidly without like breaking anything and putting it into the right bins and whatnot. So this is a very efficient system because, as you can imagine, for robots, they can be run all night long and they don't need a bathroom break. They don't need to like step outside for a sip of water. They can't even form unions and to be like, no, we need better working conditions. They just can run all night and take care of all this kind of tedious, mundane steps that I honestly think we humans shouldn't really have to deal with. So that's really amazing. Back to this, one of the things that when you have time, which would be nice to think about, is or go on YouTube to look at is the Amazon warehouses. Go ahead and take a look at some of these videos. It's actually really fascinating because there's basically no human intervention. There's these Roomba-like robots that are roaming about in the warehouses and picking up signals from like the floor of the warehouse and whatnot to know where to go and to pick up different bins and items and sort it and group it together and do all of that. So as you can see on this slide here, most companies have to go through these 5 steps in their warehouse, and it's a very complicated process. And at number 4, when you sort items, a lot of humans are involved. However, Amazon has made it so that they can completely eliminate this 4th step, basically, and the machines are basically taking care of it. The robots are taking care of it. And as you've seen, Gap is investing in this too, and a lot of other companies are looking into automating this sorting process, which I think is wonderful. This is one particular area, I believe, that human intervention is not the best option. Definitely this could be automated, and we can focus on what we're good at. Okay, beautiful. Okay, so the next thing is inventory checks and restocking. This is another area where I believe humans don't really have to take care of all of this. So you might have seen these cameras in retail stores, and a lot of the time it is for kind of tracking human behavior and whether stealing is going on and whatnot. But imagine these cameras doing some of the tasks that normally the employees would have to do. Checking the inventory. If a shelf is empty, scanning that shelf and making sure whatever items were there before can be restocked. It's available in the store, or if it's not available, can it like contact nearby stores to get it replaced, or does it really need to be reordered and restocked? All those kind of things would be very useful to for it to be automated and for the employees not have to check on this all the time. So I'll show you one company, Shelfie, is kind of one of the leading forces in this particular area, and I'll show you a little bit of a clip on that. Okay.
Visual merchandising is about first impression. You only get one shot with a customer. They're going to come into your store before they've looked at the price, before they've really explored the stock, and before they've met anyone. You want the store to look amazing, and visual merchandising is going to deliver on that. Standards have got to be high. It's not enough to have your visual merchandising looking amazing at 9 a.m. when the store opens. It's actually got to be maintained all day. You need consistency. Every nook and cranny of a retail space is important. Every shelf, what's on every shelf, how it's on every shelf, the way it's grouped with other product. It's expensive real estate, so it better be making the CEO some money because he wants to see what that turnaround on that stock is. Now that's expensive to have staff on the floor doing all of this, but that's where Shelfie comes in. That's where it really comes into its own.
With Shelfie, visual merchandising implementation and store compliance becomes a very simple and measurable task. We're partnering with Microsoft to provide a cloud-based solution that transforms the way retailers implement and monitor visual merchandising within their stores.
Shelfie really exemplifies innovation coming from our market, Australia. Took a really practical approach and working with the Lakiba team to address a customer challenge, a real customer challenge. And that gave birth to Shelfie.
Shelfie can recognize gaps and wrong products placed on the shelves in the wrong spot and provide instant feedback to team members. Instant stock feedback means instant stock replenishment.
The marketing teams and the design teams have real-time visibility into the store and what's hot with the customers, and they can really respond to those trends they're seeing in real time. They can really look at that revenue performance at a store level, as well as an aggregated level across the store network.
Shelfie can watch your store and the compliance of your stock all day. Is it right on day 1 when the store opens, or is it right on day 25 when you know where the sales are and where the sweet spots are? Shelfie will help you maintain that sales level. It's really the ideal solution for any retailer.
Shelfie really helps the store manager to get out of the back office and onto the floor, coaching their employees and engaging with customers where they're really needed.
So what I really like, and that's kind of why I went through this video for quite some time, is the thing that was said last from maybe it was the store manager, bringing the employees back to on the floor, training other employees, and really focusing on that human connection and customer experience. And that kind of goes back to what we were talking about before, about like letting the automation be taken care of. AI can take care of all of that, and we can focus on what we're really good at. So that's kind of like the message that I really wanted to make sure that came across. And I think that's the important thing that we have to think about. Okay. So the next topic is definitely very interesting, and it brings back also the conversation we were having with the initial video about, like, is it going to be robots against us, like some kind of war? Because it is a thing to say AI fashion designers. This is a thing. So as you can see here, Amazon, like anything else, they're also investing in AI fashion. And what that means is they have this lab called Lab 126 in San Francisco. And they developed an algorithm that learns about a particular style of fashion from images. And then they can generate new items in similar styles from scratch. So it's basically an AI fashion designer. And this might seem a little bit new to you guys, but actually this is already in practice. So there is a company called Mantra. It's an Indian fashion e-commerce company headquartered in Bengaluru, India. And they have launched a fully automated design collection with zero human intervention. And what they've done in particular is there's an in-house fast fashion company brand, and they're powered by AI. It's called Moda Rapido. And they basically, it's 100% computer-generated fashion collections of jeans and T-shirts and kurtas and shoes and all of that. And what's interesting is if you were to go on their site and choose like a shirt for yourself, the AI stylist, if you will suggest other items that can go along with that shirt very well. So they're, also recommending different styles that go along with also the AI-generated fashion items. And the most interesting thing, I believe, is that Moda Rapido right now is one of the brands with the highest gross margins compared to any of the other 14 brands that Mantra portfolio carries. So they're actually doing very, very well. So this is a classic example of what you might consider an AI fashion designer. One thing is, though, the items that the AI fashion designers created, if you will, are very basic items. So I do wonder, when it comes to more creative and innovative styles, whether the AI fashion designers can handle that, or even if they can handle it, is it something that we would want? That's something to think about as well moving forward. Just because something is available doesn't mean we necessarily want it or will accept it. And we'll come back to this concept again as some of the questions we might have for the future. Okay, product testing prior to purchase. This is happening in different areas, such as Warby Parker. It used to be, or they might still do it, but about 5 glasses are sent to you, and you get to try all of them on, and select the ones you want and send the rest back. Now with your camera on your smartphone, you are able to actually try on the glasses right away. I've had students told me they've tried this before, like one or two students maybe, and they were like semi-positive about it, like, oh, it kind of works and kind of gives me a good idea of what it is. But this, from the company's point of view, you can kind of see why it's so great, because there have been a lot of damages and delivery fees, and things were delayed a lot of complaints, if you can imagine, with this whole box being sent to every household in the United States. So this is one way to kind of cut costs as well. I think in terms of product testing before purchasing, I really like this company, Modaface. because you can basically change your hairstyle or hair color before actually purchasing it and committing to that. And to me, if you want to go kind of crazy and change your hairstyle, like, I don't know, something blue or red or pink, I might want to know what it looks like before I really commit to it. So this, I think, is a kind of like a nice way of doing product testing before purchase. There is also, a lot of students actually have told me they've used this, but Sephora has an app where you can try on different makeup items, lipstick. You can also take a picture of maybe a piece of clothing you might have, and with that color that the app registered, it will select different lipstick and makeup products to match with that. So all of those are happening for product testing prior to purchase as well. So those are some areas that are being affected. Another area that I'm very interested in is a subfield of computer science called recommendation systems. It's called recommendation systems. And we are actually affected by this just all the time. When you go on Amazon and buy something, it might say something on the bottom that says, people who bought this also bought this together. You go to Netflix and you watch something and say, people who like this particular film also watch these particular films. Would you like to try them? When you go to Spotify, Pandora, and you listen to some music, they will suggest something maybe similar to that. And this is all based on this area of recommendation systems, and you are getting recommendations from the system. One of the things that is used in the fashion industry is for personalized clothing, and probably among these brands, I believe Stitch Fix is the most popular one as far as I'm concerned. And what it does is it takes information from the customer and tries to recommend a style that like really is catered to you. What's interesting about recommendation systems, and it's very fascinating in my opinion, is that in the very beginning, it has a problem. It's called the cold start problem. And what that means is that it has very little data on the customer, if you will. So it's cold in terms of data because it has very little data on you. So you might notice a lot of companies these days, before you can even start browsing any of their items or even try to purchase something, they always make you do a survey in the beginning. And that's so that they can overcome this cold start problem. So, you know, it might say something, a lot of times it gets your demographics information. Like say, if it's for me, it's like, oh, well, Maria identifies as a female, she lives in New York City, and she's about this age, and she particularly likes frocks, like dresses or something. So then they'll get that information, and that's not a lot of information, but that is something than nothing. So based on that, they are going to look up the database they have on other females in New York City who also like dresses, and then start recommending me something. So they can start somewhere. So it's not completely cold, but you know, there's a little bit of data on me, or there's a little bit of data on somebody else who are demographically similar to me. And then after their first suggestion or recommendation, I'll probably give them information. I'll probably give some feedback being like, no, I don't like this dress. Oh, I do like this dress, so I'll keep it, I'll buy it. I do like this dress as well, but it's out of my price range, so I won't be getting it, etc., etc. And so from then on, there's more and more information, meaning there's more and more data for that algorithm to use to recognize patterns. And then eventually, with more and more and more data, the algorithm will get smarter and more intelligent and will be able to make those suggestions or predictions for you, going back to the definition of machine learning. So this is how a lot of the recommendation systems work, where they start out with a very poor set of data, or almost no data at all, and they keep building on top of what they have, and then over time, over a lot of data, they get better and better. And I guess the gold mine for these companies is to recommend something before you even know that you want it. We have reached one of the kind of like that era where it'll say, this is what you want, and you're like, I don't know I wanted that, but maybe I do, and then you open up your wallet, right? So those are some areas that are being affected. Voice technologies is very interesting. I always do a little survey in my class when I talk about voice technologies, and there's always definitely a number of students who have Alexas or Google Smart assistants and stuff. And it always falls under about 3 categories, in my opinion. People ask what the weather is going to be. They either turn or turn off their lights, and they play music. That's pretty much the extent of it. And that's fine. There doesn't have to be, if that's the only purpose for that, then that's fine. But you can imagine the voice technologies going a little bit further than that. And maybe it can relate to fashion, but it can go beyond fashion. For fashion, you could be ordering things, and the assistant, Alexa, for example, could have all your past transaction records, let's say at Gap, and you're looking for something, and you just, use your voice command to be like, find me a white t-shirt in the range that's lower than $40. Because I have to use it for this purpose, and go through my transactions and find some of those. Among those, choose the one that was my most recent transaction. Go ahead and buy it, and they have my credit card information. They order it for you. The next thing you know, it's in front of your doorsteps, right? It could be something like that. It's not that much crazier than what you normally use maybe an Alexa for. There are some other areas, especially when it comes to your day-to-day life, when it comes to food and stuff, where voice technologies could be used. I haven't seen it in a lot of places, but there are these smart refrigerators, where the refrigerator will be able to detect the remaining ingredients in your fridge, and also know the expiration date, and like suggest recipes to use all of it. And in particular, I was indirectly involved with a research team that was looking into how voice technologies could assist in managing chronic diseases. So let's say if you're a diabetic and you have to manage your glucose level, the smart fridge, for example, could scan items and maybe suggest recipes with the items you already have, ingredients you already have, to make a low-carb meal for dinner or something like that. And then talk to Fresh Direct or Amazon Fresh or Whole Foods or whatever to place some orders that you will need to replenish, and do that automatically for you as well, right? So a lot of these things could be integrated and be kind of present in your day-to-day lives. Whether, so I haven't seen that a lot. That's another thing that comes back to the question of, just because something's available, do you want that to be part of your life? That's something to think about. And the fact that it isn't very pervasive now maybe does say something about our preferences, right? Something to think about. Okay. So kind of wrapping up here, where do we go from here? And we just talked about this, right? Just because if something's available, do we really want it? So there was a philosophy professor at Stanford who was asked about, got a question saying, will robot musicians ever exist? And to that he said, yeah, maybe someday, I can see that, but only if we first figure out what it means to have robot philosophers. And so the idea of this is, it's based on this article, Humans in the Loop, the Design of Interactive AI Systems. And what we really need to think about is this blind spot in the way we talk about the future of AI. In our tendency to ask whether or when a given task will be taken over by automation, it is easy to ignore the deeper issue of what such a takeover would mean. So this is something to think about moving forward, I think. Just because something is available and it could be used doesn't mean we necessarily have to adopt it. But even if we do adopt it, like, well, what does that mean to adopt it? What does it have a significant meaning to us when we do adopt it? Or let's say we do want it. Like, what do we really want from it? Just because there's going to be robot musicians, and that could be very cool, do I want to listen to music, like be at an orchestra where all the musicians are robots? Something to think about. It's an interesting question because there are a lot of things where, you know, there were very innovative ideas that didn't take off. And in business, we talk a lot about there's also the timing, but really market acceptance. Is it ready? There's a lot of things that were done first, but it didn't take off at the time it was first invented, but later on it picked up. Even with the craze of AI and machine learning, this is not a new concept at all. If anything, AI was first coined in the year of 1956 by a Dartmouth professor, John McCarthy. And there have been several waves of popularity of AI and machine learning, but this is kind of like the fourth wave, if you will. And the reason is because unlike previous times, we are so much better at collecting data. We have these wearable techs and our smartphones or computers, and just every second and millisecond of the day, data is being collected. So with a lot of that data, and we know with the definition of machine learning, the data really feeds into the algorithm to make these predictions and do all different things that we talked about. So because we have so much data now, to the point where we have more data than we can handle and analyze, now there's like another huge wave of popularity with this. So timing is important, and the meaning of all of this is important to realize if all of this is what we really want. Okay. All right. So with that, I think I will end my talk here. I would like to thank you for listening in. And at some point, hopefully, maybe, as I said before, we can get some questions and talk more about these ideas. But hopefully this gave you kind of like a good introduction to what AI and machine learning is, and also how the applications are affecting the fashion industry. A lot of these things are maybe not the most recent one. There have been a lot of changes in the industry, I'm sure, with the COVID-19 pandemic and how a lot of things are going virtual. And that's another area that I'm going to do a little bit more research on to learn about. But it'll be interesting to see where we go. And then again, as we move forward, where we might be headed or where we might be able to go is not necessarily maybe the question we need to focus on, right? Even if this is a possibility, is that really what we want? And what will that mean in terms of taking on that particular path? All right. Thank you very much, and hopefully I will get to talk to you soon.